Woodworking is messy, and just about every woodworker I know has chased after the same dream: to keep all the sawdust off the floor and the dust boogers out of their noses. In the United States alone, nearly $1 billion a year is spent on wood dust collection, and a lot of those hard-earned dollars are wasted because most small shop folks are following bad advice and making preventable and costly mistakes. If you've ever wanted better dust collection in your shop, you're going to be glad you found this video, because I'm going to give you a crash course in dust collection, focusing on the most common mistakes people make. This isn't just a list of obvious stuff. I've made many of these mistakes myself over the years, and I had to learn some hard, expensive lessons. By sharing that experience with you, I hope to save you a lot of heartache and a ton of money. So let's get started. Like many of you, I started out with a shop vacuum. It worked pretty well on certain tools, such as when I connected it to that little port on the fence of my router table or to my random orbit sander, but it was useless on larger tools like table saws. That's because a shop vacuum moves a limited amount of air at high pressure. When you can get the end of that hose right next to the source of the chips, it does a decent job at collecting them. But as you back the end of the hose away from the source of the chips, you lose the ability to collect them effectively. That's why a shop vac works well on a router table fence. It can suck the chips right off the bit. But the dust ports on most other machines, like table saws, are far from the source of the dust. So while there is a place for shop vacuums in a workshop, such as for handheld power tools, they have limited value for dust collection on most larger machines. Like most woodworkers, I eventually transitioned from a shop vac to a single-stage dust collector, and I thought I had it made. Impeller-driven dust collectors, such as this one, work differently than shop vacs. While shop vacs move a little air at high pressure, a dust collector moves a lot of air at low pressure. How much air? Well, this Harbor Freight collector boasts the ability to move 1,500 cubic feet per minute. And that, like the airflow claims made by every single-stage dust collector brand out there, is total nonsense. They measure the system's airflow with no filters attached, no collection bag, no ductwork, no hoses, no blast gates, not even any machines connected. So how much air will it really move in an actual woodworking setting? Well, if you don't make any of the other mistakes we'll discuss in this video, your single-stage collector might move enough to collect the chips that you would normally sweep up with a broom. Not the fine dust in the air. It won't do a great deal to help keep your lungs clean, but it may keep your shop clean. And if you understand and accept those limitations, a small shop woodworker can get by just fine with a single-stage dust collector, provided he doesn't make many of the other mistakes we're going to cover. On the other hand, if you wish for more than just keeping your floors cleaner, you may consider a large cyclone-style collector. This doesn't mean slapping a cyclone-shaped object to your single-stage collector. Adding a cone to an underpowered system is not going to make it more powerful. These aftermarket cyclone attachments are designed to help with dust separation after it's been collected. They will not make a single-stage system pick up more sawdust. We'll talk more about that shortly. But don't confuse a cyclone add-on with a well-designed cyclone system that features a large impeller and a powerful motor. These proper systems move far more air than a single-stage dust collector on the market. They allow you to attach more complex ductwork and more machines at the same time. This is a dust collection system that can be run throughout a shop, and this is a chip collector that can service one or two machines. The biggest mistake I made early on was thinking I could connect a bunch of ductwork to my underpowered system. It began with my shop vac. I bought a kit that included some 2.5-inch piping and some fittings and even some blast gates. I ran the main duct along the wall. It branched out to various tools, just like a real big shop ducting system. Or so I thought. I quickly learned that every foot of duct, every inch of hose, every T and every Y and every elbow increases the resistance to the precious little airflow that a shop vacuum produces. In the end, I got a lot of clogs and I ended up ripping it all out, more money wasted. I'm not saying you can't make a simple shop vac ducting system with a couple blast gates, but shop vacuums work best when you attach them directly to the tool with no more than a few feet of hose. Now what about single-stage dust collectors? Can you attach ducts to them? Yes, but the same principle applies. The more ducts, hoses, and fittings between your tool and the dust collector, The more airflow you'll lose and the less chips you'll collect. So keep it short and simple. What about ducting material? Because it's all about airflow, you want ducts with the smoothest inner walls possible. PVC features the lowest friction surface of any ducting material, even metal. On the other hand, metal ductwork often features smoother transitions between the pipe and the fittings. This is a big factor as well. If you have a complex system with a lot of fittings, high-quality steel ductwork that's specifically designed for dust collection is your best option. It's also easier to disassemble and modify than PVC, but it will likely cost you a small fortune. Notice I said steel ducting should be designed for dust collection. I once built a complex system with HVAC pipe from the hardware store because it was way cheaper than 6-inch PVC. It was a disaster. For one thing, HVAC pipe is designed for air that flows away from the blower, not toward it. So all the seams are backwards, creating ridges that catch the chips and they slow the airflow. And those seams are not well sealed. The system leaked like a sieve unless I covered it with tape. In the end, I tore it all out too. That was a lot more money wasted. If you can't afford high-quality steel dust collection ductwork, PVC is a far less expensive option, and it's readily available in 4-inch diameters, and you can also find it in 6-inch if you do some searching. And yes, you can use PVC for ductwork. The internet may be full of horror stories about static discharges starting fires. That may be a risk in large industrial shops that generate massive amounts of dust, but not in a small one-man shop. Even so, if you're worried, there are videos out there that show you how to ground your system to discharge the static electricity. And that brings us to the issue of duct sizing. You must size your ducts to the dust collector you own. If the ductwork is too small, it will restrict airflow and therefore the suction. If it's too large, it will create too much resistance, reducing air speed, and the chips will pile up inside the ducts. Without going through the math, I'll tell you that a single-stage dust collector is best connected to 4-inch ductwork. A powerful cyclone collector can handle 6-inch or larger ductwork. But the size of the ducting isn't the only factor. The port on the machine is the bottleneck. At the pressure that dust collectors generate, air does not compress. So you can't reduce a 4-inch duct or hose from a dust collector down to a 2.5-inch port on your small machine. You'll starve the system for air. That'll produce minimal suction. Small ports are for shop vacs, not larger dust collectors. On my router table fence, I do have a 2.5-inch hose connected to the fence that branches off of a 4-inch hose which services the larger port on the underside. Together they do a serviceable job, but a shop vacuum connection at the upper port would collect more dust right off the bit. And forget about reducing your 4-inch dust collection hose down to the tiny little port on random orbit sanders or other small power tools. It just won't work. Use a shop vacuum for that. If you do decide to run ductwork in your shop, choose your fittings wisely. I've made this mistake several times. I've used too many fittings, making the system too complex with too many bends. Air running through your ducts is like a car traveling through a tunnel. It can move fast on a straight run, but it has to slow down for a curve. The tighter that curve is, the more it has to slow down, and a 90-degree turn is a momentum killer. A T-fitting then is a bad choice. If you must split a main into 2 branches, use a Y. Likewise, a tight 90-degree elbow is a poor choice. Instead, use 2 45-degree elbows with a foot or so of pipe between them to create a more sweeping curve. But keep in mind that even a sweeping curve will slow the airflow a little, and several fittings in a row, together with any flex hose that may be in the line, is all going to add up. So keep it simple. Some powerful systems can be connected to multiple machines simultaneously. Others, including pretty much all single-stage units, have to be connected to one machine at a time. If you don't stretch a hose directly from the dust collector to the machine, you'll have to use ducts and blast gates to control the airflow. While blast gates are essential, they do create some issues that many folks aren't aware of. For example, some must be installed so the air will flow through them in a certain direction. They'll leak if you install them backwards. You can usually identify these by the little screw that puts pressure on one side of the gate. Many blast gates also accumulate dust in the slot behind the sliding portion. Over time, this gets packed in until the slide will no longer close fully and it'll leak. You may install it so the slide opens downward and the dust in the slot can fall out, But this orientation is not practical in many cases, and on some blast gates, the slides will fall open in that position. While I don't understand all the science involved, experts smarter than I am tell me that the more pipe between the tool and the blast gate, the more resistance in the system. They recommend keeping your blast gate near the main duct line rather than placing them directly at each machine, even though this may be less convenient. It was also recommended to me to use blast gates to shut off entire sections of my large duct system when it's not in use, essentially making a very complex system behave like a much smaller one. I believe this has something to do with preventing the whole system from being pressurized every time the blower's turned on. But there's another reason to close off sections of a complex system when they're not in use. It eliminates leakage. Every fitting, every hose connection, every blast gate is a potential leak. You may not even know you have them, but they can all add up. When I close off portions of the system, I eliminate all potential leaks in that section. That reduces perhaps a dozen leaky connections to one, the blast gate. Another mistake I made early on is also one I see a lot of woodworkers on YouTube make. They use way too much flex hose. Hoses with ribs produce a tremendous amount of resistance to the air moving through it, up to 9 times the resistance of smooth pipe. Think of these as hundreds of little speed bumps. The air in the chips will slow down as they pass through, and slow airflow can't carry the chips far. You should use as little flex hose as possible. If you have a ducted system, run the PVC as close to the machine as you can, and then finish with as little flex hose as possible. If you run a hose directly from the dust collector to the machine, limit your hose to a few feet. If you're using 20 foot of hose, move your dust collector closer to the tool and shorten that up. You may be surprised at the difference. Flex hose connections are also notoriously leaky. I recommend clamps that are designed for that purpose with bridges that produce more even clamping pressure over the ribs. It's common to attach what's called a dust sweep to ductwork, which acts as a dustpan to suck up everything you broom into it. But you should be aware that fires have started this way. In some documented cases, screws or other pieces of metal were sucked up and a spark was created when they struck the steel impeller of the dust collection's blower. That spark then smoldered in the dust bag for hours or even days until a fire was ignited. Shops have burned down from this. One way to mitigate the risk is to attach rare earth magnets to the dust sweep opening and hope that any metal sticks to the magnets, but I'm not sure that's completely effective. A trash can separator or cyclone system may also separate the chips and metal out of the airstream before it reaches the impeller. We'll talk more about those shortly. One of the least understood parts of woodworking dust collection are the filters. Older and less expensive single-stage dust collectors come with filter bags that let all sorts of dust through. Worse yet, they suck up the dust from your tools, which are around waist level, and then they pump it out through the pores in the bag at nose level, which disperses it through the shop where you may end up breathing more of it in than you might have just standing in front of the saw. That's why many people call single-stage dust collectors dust pumps. Incidentally, if you're thinking of washing your filter bag to clean it all out, don't do it. It likely contains a special coating that reduces the size of the pores, and washing it will ruin it. Many bag filters also rely on a buildup of dust in the fabric to close up the pores even more and provide better filtration. You don't want to remove that crusty dust. So why don't they just make a filter bag with finer filtration? Because the finer filtration, the less overall suction. You see, for air to come into the collector, it must also escape out through the filter. The smaller the holes or pores in that filter, the less air that can escape. The solution is to add more tiny pores, but there's only so much room on a cloth bag. To make the hole small enough to keep all that dangerous fine dust from escaping, you may need many, many times more square footage of filter material than the typical bag has. The solution then is a canister filter. This is full of pleated filter media all folded up inside. It provides many times the square footage of a bag, and it can also filter out much, much finer dust. A canister filter will not only keep your air cleaner, it will also improve your suction because it won't restrict the airflow as a filter bag does. Remember, they rate dust collector airflow with the filter off. When the bag filter goes on, the airflow is cut down dramatically. A canister filter will go a long way to restoring it. I've tried trash can style separators over the years, including the plastic lid type and the baffle design. They have some advantages, particularly in the way they keep all but the finest dust from reaching your filters, which extends the time between your filter cleanings and their overall lifespan. But the trade-off is they reduce airflow. Some reduce it by more than 50%. If you already have an underpowered single-stage system, you can't afford to lose any more airflow, especially if you hope to hook up some ductwork. I'm not saying I'm against separators. There are mini cyclone attachments on the market that I haven't tried. Some folks really like them. But keep in mind that everything you attach to your dust collector will reduce its airflow to some extent. If you're going to attach a separator, you may have to compromise elsewhere, such as simplifying your ductwork or shortening your hoses. As I said previously, adding a cone to an underpowered system will not make it more powerful. A cyclone only affects chip separation after it's already sucked up. It won't make a single-stage system pick up more sawdust because the small impeller it has is underpowered and only capable of moving the air that's already moving. That said, if a separator will keep your filters cleaner, that will keep your system at peak efficiency longer. As with everything, there's a trade-off. If you want to try a separator, just be sure you can take it back if it doesn't work well in the system you have. I've thrown a lot at you, so let's sum it all up. Shop vacuums are good for tools with small ports. Dust collectors are good for tools with 3-inch or larger ports. Single-stage units are for collecting the chips you would normally sweep up with a broom. Large cyclones will provide much better overall dust collection. If you plan to connect your dust collector directly to one machine, don't use 50-foot of flex hose. If you plan to attach it to multiple machines, keep your ductwork simple. Use as few fittings as possible, avoid any tight bends, and limit your use of flex hose. Size your ductwork to your system. That means 4 inches for most single-stage collectors. And don't starve your system by reducing a 4-inch line down to smaller than 3 inches. Remember that leaks can add up, so keep your connections sealed and your blast gates clean. And it's all about airflow, so consider upgrading to a canister filter. You'll be surprised how much it helps. On the other hand, beware of things that may reduce airflow, such as trash can separators. Follow these rules and you'll avoid a lot of heartache and save a lot of money. Now here's another good idea. It's just a couple of cuts. Your ears will be fine, right? They will be if you have your IsoTunes Bluetooth earbuds in, because you'd already have your ANSI certified hearing protection on because you're listening to your favorite music and podcasts. And you're supporting a small family business at the same time. Please use the link below this video to learn more and to show them you support what we do as well.